Hello, welcome to MathSci Hub Catch-up Lessons, where we deal with everything math and science for grade 11s and grade 12s. Continuing from last week we did exponents. This week we're gonna do equations and inequalities. This is, I think, question 1 and question 2 of your question papers. Like I said, these lessons are based on past question papers, so we try to explain and give you an insight of how your question papers will look like when you start writing your exams. And one of the satisfying things that a teacher normally gets when he's busy going through his lessons is actually what I normally call a light bulb moment. When you're busy going through your lesson and then you see a learner, the face actually lights up, and then you actually get to see that they're actually understanding what you're trying to explain through your lesson. So hopefully during this lesson I will be able to provide you guys with one of those light bulbs moment where you actually, your face lights up and then you understand what I'm actually trying to explain to you guys. All right, let's start. Like I said, we are going to deal with equations and inequalities. And there's different methods of solving these equations, and basically these equations we call them quadratic equations, and there's different methods in solving these quadratic equations. One of the methods that we are going to explain is factorization. The second method that we are going to get through is completing the square, and then substitution, and then using the quadratic formula. Now, when solving quadratic equations, there's a standard form that is there and that you need to get whatever expression that you are given. You need to get your expression into what we call a standard quadratic form. A standard quadratic form is basically ax squared plus bx plus c equals to 0. Right? This is the basic quadratic form. So whatever expression you will be dealing with, try to get it into this basic quadratic form. So let's go through our first example. So I'm going to do a few examples before I get to the question paper, so that you guys have a clue and an idea of what we're actually dealing with. So let me start with the first example. So the first one says solve for x, and we have 3x over x plus 2. I'm sure by now you guys are used to my handwriting, so it's not a bit confusing to you guys. And then we have 4 over x plus 1. Now, looking at this expression, first thing that you need to think about, is it in a standard form? No, it's not. So try to get it in a standard form before you solve for x. Part of our expression, we have a fraction, right? Now, when we deal with expressions that are fractions, as you might know, I think you've been taught this, is to try to get rid of your denominator. How do you get rid of your denominator? By finding your LCD. Lowest common denominator. Your LCD. Now let's try to tackle this. Now in this case, we have 3x over x squared. We have 3x over x squared, and then on the other side of the equal sign we have 4 over x plus 1. Now we are going to try to have the same denominator. On this side we have this part, and on this side we have this part. How do we get that? Now in trying to get your denominators to be the same, you need to find your LCD. So meaning we're going to have to multiply this side by x plus 2 and x plus 1. What you do on top, you do also at the bottom, meaning we are going to do the same here, which is x plus 2 x plus 1 multiplied by 3x over x plus 2 plus this side here. So whatever we did here, we are going to do also to this one here, right? We are going to multiply this to the one here, meaning we are going to get x plus 2 x plus 1 all over x plus 2 x plus 1. Moving to the other side of our equal sign, whatever you do on the left you do on the right as well, meaning we are going to multiply this as well. 4 times x plus 2, let me just write on top, x plus 1, right, all over x plus 2 x plus 1. All right, now from here we can see that we can cancel out the x plus 2. It cancels out with this x plus 2, right? This will leave the same. Now on the other side, our x plus 1 will cancel out with the x plus 1 for this expression here, right? Meaning now we are left with, now can you see, now we have the same LCD, we have the same LCD, we have the same denominator, right? So your denominator is made up of x plus 2 bracket x plus 1, same as this side, same as this side. So meaning, since we managed to get our denominators to be the same, we can drop the denominator, right? Now after dropping the denominator, you are left with 3x into x plus 1 plus x plus 2 into x plus 1 equal sign. If we multiply this 4 but by this expression here, we are going to have 4x plus 8. Now can you see we've managed to get rid of our denominators by finding our LCD and then cancelling out what we need to cancel out. Now from this point on, we need to get our equation into what? The standard quadratic form. Meaning now we're going to have to distribute. We're going to have to distribute. We're going to distribute the 3x to everything that is in the bracket. We're going to have 3x squared plus 3x, right, plus x squared. We get rid of this bracket. It's going to be x squared times x times 2x times 1. Meaning we're going to get x squared times x times 1 times 2x. We add them, we get 3x. Yes, we're going to get 3x. And then here we get 2 equals 4x plus 8. Now let's try to get everything else on one side. We're going to get everything else on one side. We're going to get everything else on one side and equate everything else to 0. Meaning we're going to have, let me get a highlighter for this. Let me get a highlighter. We have 3x, we have x squared, and then we have 3x and 3x, and 4x on the other side of the equal sign, and then we have 2 and 8. All right, I've highlighted our like terms. Now in this case we're going to get 4x squared. It's going to be 6x. If we take the 4 to the other side, it's going to be negative, meaning it's going to be negative 2x. If we take the 8 to the other side, it's going to be negative 6. It's going to be negative 6. It's going to be negative 6. Now, before we continue trying to get our factors for this sum, if you have an expression which is fraction based, what you need to do is to find your restrictions. By restrictions, remember, if you divide anything by 0, you will get an undefined answer, an undefined solution. Now, whatever we get after factorizing, we don't need to have an undefined denominator, an undefined answer, meaning your denominator mustn't be 0. Now in this case, our restrictions, let's say you get negative 2 as your x here. If you get negative 2 plus 2, you will have 0 in your denominator, meaning it will be undefined. If you get negative 1 as your answer, your denominator will be 0, meaning your solution will be undefined. So in this case, your restrictions are your x should not equal negative 2, and again your x should not equal negative 1, right? So these are your restrictions. You, after getting your roots or your solution, they mustn't be -1 or they mustn't be -1 because they are undefined, right? I'm just gonna rewrite the last part of our equation here, of our expression is 4x squared. It's 4x squared minus 2x, is it plus 6 or minus 6? And then it's minus 6. It's minus 6. Now we've managed to get our expression in what we call a quadratic standard form. A standard form for a quadratic equation, right? So this now is in this form. It's in this form. It's in the form of ax squared plus bx plus c. Now let's try to get our terms for x. Let's try to get our terms for x. Now you guys have been taught different ways of trying to get the factors for x, right? You've been taught, but the method that I normally use, but then let me try to simplify this by dividing by 2, meaning we're gonna have, if I simplify this, we're gonna have 2x squared minus x minus 3 equals 0. Now what I normally do when I try to get the factors is try to get the factors of 3. Try to get factors of 3, meaning what are the numbers that I need to get, or which numbers, if I multiply them, I get 3. Which numbers am I going to use, or which numbers am I going to get if I multiply them? I get 3, meaning the factors of 3. The factors of 3. Now factors of 3 are simple in this case. It's only 3 and 1, right? 3 and 1. Now let's do this. 2x, x. Like I said, factors of 3 is 3 and 1. So let's say here we have minus 3. Let's say here we have plus 1. Let's check if we get same answer. It's gonna be 2x squared. It's gonna be 2x, 3x minus 3, meaning you've managed to get your factors. We have 2x minus 3 equals 0, or x plus 1 equals 0. So x would be 3 over 2, or x equals -1. Now remember, I said if you are dealing with an expression that has fractions, what do? You need to determine your restrictions. Now in this case, we have your x as 3 over 2 and your x as -1. Let's go back to our restrictions and see what x mustn't be. And let's get back to our restrictions. Your x must not be -2. Your x mustn't be -1. So look, we have x as -1, meaning after writing your final answer, what you do is just put a line across your equal sign. Just put a line across your equal sign and say your x should not be equal, should not equal -1. Right. Let's move on to our next example. Remember, I said we are going to deal with factorization, and we just did an example. We just did an example of factorizing, and the next one that we are going to do is completing the square. Completing the square. Now this example, you solve for x by completing the square. Now there's a unique step in which you need to follow when you complete the square. Now in this case, what you need to do first is check your coefficient of x squared. First thing that you need to do here is try to check whether you have 1 as your coefficient. Try to check whether you have 1 as your coefficient. Now in this case we have 1 as our coefficient. Let's say we had 2 as our coefficient. The first thing that you are gonna do before you start this is divide everything else by 2, because you need to get 1 here before you start. But now it's much simpler because our coefficient in this case is 1. Now like I said, there's a step that you need, there are steps that you need to follow when you complete the square, right? It's x squared. Now the first step that you need to do is take the 11 to the other side of your equal sign, right? Take the 11 to the other side of your equal sign, meaning it's going to be positive 11, right? It's going to be positive 11. Now the second step that you do is take the coefficient of x here. Take the coefficient of x here, and what you do with it is you multiply it by a half, and then you square it, meaning you're gonna get minus 10 times half, it's 5, and then you square it, meaning it's gonna be 25, and then this 25 you put it back to your equation. And then you also put it back here. What you do on the left, you do on the right. So whatever I insert here, I also need to do on the other side. Meaning now we are going to have x squared minus 10x plus 25 equals 11 plus 25 11 plus 25 okay, it's x squared minus 10x plus 25. If you add this, we get 36. Now from this step, what you do is try to get the factors of x. Now in this case, we have x minus 5, x minus 5. Remember the method that I think is much easier. What you do is, what are the factors of 25? What are the factors of 25? Once you get the factors of 25, in those factors, which numbers do I add to get the 10? You get the factors of 25. After getting the factors of 25, which numbers do I need to get to -10? Now in this case, 5 and 5 are factors of 25. And then if you add them, you do get a 10, right? Now can you see now we have a perfect square, because we can write this whole thing now as one thing and then square it. We will have x minus 5 all squared equals 36. X minus 5 all squared equals 36. Now remember, we are solving for x, meaning we need to get rid of this square. We need to get rid of this square. How do we get rid of a square? By using what? A square root. Now in this case, we are going to say square root of x minus 5 square root of 36, and then we are left with x minus 5, and then the square root of plus or minus. Remember, the square root of 36 is 6. If we take the 5 to the other side, we will get x equals 11. X equals 11. Now guys, it's very helpful after getting your answer to go back to your original quadratic equation and try to double check and try to check whether you got the right answer. And you know how you check that? By substituting your x, sorry, I'm trying to get a highlighter here, to the original equation, and if you get a 0, it means you're on the right path, your answer is correct. All right, let's move on to our next method of solving quadratic equations. The next method of solving quadratic equations is the method that we call substitution. The method called substitution. Now let's pick up an example. Let's say they say to you, solve for x, and then they give you this sum, 2x minus 3 over x squared minus, let me just rewrite this, x squared minus 2x equals 2. Now when you solve for x using substitution method, what you need to check, or what you need to figure out, is which terms are repeating themselves. Now in this case, we have x squared minus 2x minus the very same thing, but then it's in the denominator. We have x squared minus 2x minus 3 over x squared minus 2x. Now in this case, we can see this expression repeats itself. Right? Now you can solve this by using substitution method, or what is normally called the K method. Now before that, like I said, when you're dealing with expressions which are fractions, what you need to do is to check your restrictions. Check what x mustn't be as your solution, or the roots, right? Now in this case, we have the denominator here. Now what needs to happen here for x to be 0? Let's say you have 2 and a 2 here, right? You have 2. Let's say your final answer is 2 and you have a 2 here. So 2 squared will be 4 minus 2 into 2 times 2, meaning it's going to be 4 minus 4, which will end up giving you 0, meaning your restriction is your x should not equal 2, because once you get a 2, your denominator will be 0. Your denominator will be 0. Now, after setting out your restrictions, like I said, look at which expressions repeat themselves. Now, in this case, it's x squared, minus 2x, and here we have x squared minus 2x. Now, you need to set, your next step is you need to assign a variable to this. And then you say let, my L looks like an E, so let me just write it like this. Let k equal whatever term is repeating itself. In this case, it's x squared minus 2x. It's x squared minus 2x. Now, substituting k into our equation, you will get k minus 3 over k equals 2. Now let's get rid of our denominator. Let's get rid of this k, meaning we're going to multiply everything else by k. We're going to multiply everything else by k. And if we do that, we're going to get k squared. You're going to get k squared minus 3 equals 2k. Let's get everything else on one side, meaning we're going to get to k squared minus 2k minus 3 equals 0. Now let's get the factors of k. Okay, so it's negative 3 and then plus 1. Let's double check. It's k squared, it's k, it's negative 3k, it's negative 3, meaning now your k equals 3 or your k equals negative 1. Now, after getting your factors for k, you go back to your original equation. And then substitute your k. Let me get a clean board. And I said your k equals 3 or your k equals to 1, right? Let me check again. Now going back here, let's start by substituting the 3 first. Let's substitute the 3 first. So it's k equals x squared minus 2x. Like I said, let's start with the 3 first. Let's put the 3 in the space of k, meaning we're going to have 3, equals x squared minus 2x, and then let's get everything else on one side. We're going to have x squared minus 2x minus 3 equals 0, and then as we normally do, we get the factors of x. This case is minus 3 plus 1. So your x equals 3, and or your x equals negative 1. Now let's substitute again the minus 1, right, from our original equation, meaning we're going to have minus 1 equals x squared minus 2x. Let's get everything on one side. It's x squared minus 2x plus 1. Let's get our factors. Our factors in this case is minus 1 and minus 1. So x equals 1, because we can write this as one thing, because we have a perfect square on this other side. Meaning now your final answer, therefore your x equals 3, or your x equals negative 1, or your x equals 1. Now before you do this, remember you have to check your restrictions again. Let's go back and check our restrictions. Now in this case, your x mustn't equal negative 2. Do we have that as our solution? Do we have that? Okay, let me check. Do we have that as our solution? No, meaning all our roots apply to our solution. All our roots, or the solution applies to our equation. All right. Now let's look at another method of solving quadratic equations. You can solve the quadratic equations by using a quadratic formula. Now before I continue on this method, in your question paper, it's either you will get a question that will state on how to solve that quadratic equation, like in the previous method that we just did. When you complete a square, it would normally state that solve for x by completing the square, or you can determine, or by actually looking at the sum, you can see that there is a term that is repeating itself. So meaning from here I need to solve for x by completing the square. And another method, factorizing your quadratic equation. You can clearly see when you get your sum that, you know what, do I have factors here? And if you have factors, it's a straightforward method of solving the quadratic equation, right? And another method is solving the quadratic equation by using a formula. Using a formula is it's normally used if you don't get the terms for x, if you don't get the factors for x. So you normally use the quadratic formula if you don't get your terms for x, right? Now remember, I said you need to get your expression into a standard form, right? And this is our standard form. Now in the previous method that we just did of completing a square, we get a quadratic formula. And you can actually derive the quadratic formula is derived from this equation. It's derived from this equation by completing the square. So if you follow the right steps in completing the square, you will end up with your quadratic formula, which is x equals minus b plus minus square root of b squared minus 4ac all over 2a. Now if you complete the square on this quadratic equation, you will end up with your quadratic formula. And this is actually a nice way of practicing on how to complete your square. You actually get to understand the method of how to complete the square if you complete the square of your quadratic equation. So let's look at one of the problems which we need to solve using our quadratic equation. Let's say you have 7x squared plus 3x minus 2 equals 0. Now I'm not gonna try to find the factors here, but you can do it on your own as I try to explain this, but you won't get factors for this sum here. So what you need to do is use your formula. But the question normally says, in this type of question, for you to know whether do I need to complete the square, do I factorize, do I use the quadratic equation, the question will normally say solve for x, and your answer should be corrected to 2 decimal places. Now once you have that at the end, at the last part of your question, what should come to mind is I should use the quadratic formula. If they say solve for x and then your x should be to 2 decimal places, what should come to mind is I need to solve this by using the quadratic equation. And another the way of putting the question, they would say solve for x by completing the square, which is quite obvious. You complete the square. Or they would just say solve for x, meaning it might be a straightforward factorization. Now, how would you know what method do I need to use in solving for x? Like I said, it will state solve for x, and then your x should be correct to 2 decimal places. First thing that should come to mind is I use the quadratic formula. and then they would say maybe solve for x in a particular expression, and then you see repeating terms, or you see an expression that is repeating itself. First thing that should come to mind is I should use substitution method. Or they say solve for x, and then by just looking at the sum you can see that, you know what, this is straightforward factorization, right? Now in this case you can't get the terms for x, and then they said, let's say for instance they said solve for x and then to 2 decimal places, meaning you're going to use your quadratic equation, right? Now this is easy. This is in your standard form. Let me rewrite it. This is in your standard quadratic form. It's in this form. It's in the form of ax squared plus bx plus c equals 0, right? Now what do you need to do? Identify your a, identify your b, identify your c, and then you can rewrite your quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now from this point on is straight substitution. Now for your b you have 3. For your b you have 3, which is minus 3 plus or minus the square root of, again your b is 3 squared plus 4, your a is 7, and then your c is negative 2. It's negative 2 all over 2a. Your a is 7. Let's add and minus what we have in our root, which is minus 3 plus or minus the square root 3 squared. Let me rewrite the square root again. 3 squared, we have 9, and then we have 4 times 7 times 2, which is 56. Remember this minus sign here, don't forget this minus sign here, meaning it will be minus 56 all over 14. 2 times 7, right? 56 minus 7, 49. So it's minus 3 plus or minus the square root of 49 all over 14. Now the square root of 49, it's 7. So it's 3 plus or minus 7 over 14, which is a half. So meaning we have 3 plus or minus a half. 3 plus or minus a half. So 3 plus a half, or 3 minus a half, meaning your x, let me just write this on top, meaning your x will be 3 minus a half is 2.5, and then 3 plus a half, your x again should be 3.5. 3.5. So those are your factors for x. Those are your roots for x. Moving on to our next example. Actually, I think now we're done with examples. We have dealt with examples that you need to solve a quadratic equation, and there are different methods in which you need to understand and in which you need to apply. The first method that we did is by factorizing, completing the square, substitution, and then solving a quadratic equation by using the quadratic formula, right? Now in a question paper you will get one or two of these type of questions, right? Now let's look at the first question in one of the question papers. This one was taken from Department of Education, November 2015, paper 1. 2015, paper 1. Now again they say solve for x. They say solve for x in this equation, x squared plus x minus 12 equals 0. Now by looking at this, they just say solve for x, right? They didn't say which method you must use. First thing that you need to do, or first thing that needs to come to your mind, can I factorize? Can I factorize this? Let's see. Yes, you can factorize. Do I have factors of 12? And what are they? They are 6 and 2, 4 and 3. And again it's 12 and 1, right? From these factors, which ones am I going to use to get 1 here, right? If I multiply these terms, I get 12, right? But then if I add them, how am I going to get 1 here? Now 6, if you add them and if you minus them, you get a 4. 4, you're gonna get a 7. If you minus it, you're gonna get a 1. 12, you're gonna get 11. If you add it, you're gonna get 13. Meaning we can use 4 and 3. We can use 4 and 3. We can use 4 and 3. We can say plus 4 minus 3. So your x should equal -4, or your x should equal 3. So this would be your final answer. Now let's move on to our second one. Let's move on to the second sum. Again, you solve for x. This is taken from this very same paper. You solve for x 2 to the power of x root x equals 2 to the power of 27, right? 2. So what do we need to do here? You have your x as exponents. Now we need to get them down, right? We need to write them as variables, and we need to get rid of this root here. Now remember, a root of something is same as, in this case we have a root of x, which is the same as x to the power of a half. So let's write this root of x in this form, meaning we are going to have x, 2 to the power of x times x to the power of a half equals 2 to the power of 27. Now here you need to apply what? Your exponential laws. We have the same base. What do? We add the exponents, meaning you're gonna add the half to our invisible one here. You get add the half to our invisible one here. Let's do that. So I'm gonna do that on the side, meaning you're gonna have 1. Let me write it so that it's clear to you guys. X and half, right? We have the same exponents. We have the same bases. We add our exponents, meaning you're gonna have to add 1 plus a half, which is 3 over 2, right? Which is 3 over 2. Going back to our equation, in this case now, after doing this, we can have 2 to the power of x to the power of 3 over 2 equals 2 to the power of 27, right? Now life has been made much easier for us because we have the same base, meaning we can drop our bases. And write this as x to the power of 3 over 2 equals 27. And now we need to get rid of this power here. How do we get rid of it? By multiplying it by tip and timesing. And in this case again, on this side again, we're going to tip and times. Now 27. Let's try to expand 27. Let's try to get the prime basis of 27. The prime basis of 27, which will be 3 to the power of 3. Let's write it in this form, right? Meaning we're going to have 3 to the power of 3, 3 to the power of 3, and then here we have x to the power of 3 over 2. Like I said, we can tip and times to get rid of the 3 to the power of 2. Whatever we do on the left, we're going to do on the right as well. Meaning we are going to have, if we tip and times, we are going to have your x would be equal 3 to the power of 3 over 2. Now if you tip and times here, we're going to have 2 over 3. The 3's are going to cancel out, meaning we are left with 3 squared, which is 9. So your x will be 9. Your x will equals to 9. I hope that makes sense to you guys. Let's move on to our next question. Our next question, they say again, you need to solve for x. You need to solve for x. In this case, they gave us x. They gave us root of 2x plus 1 equals x minus 1. Now, how do we get rid of this square root? We get rid of the square root by squaring the expression. Let's square the expression to get rid of our root here. meaning we're gonna have 2x plus 1, 2x plus 1 squared. And remember, whatever we do on the left, we do on the right, meaning we're gonna have to square everything again on the right. Now we get rid of our square root, meaning we are left with 2x plus 1 equals x squared minus 2x plus 1. Let's get this into our standard quadratic form. We are going to have x squared. Take the 2 to the other side. We're going to have 4x. And then we take the 1 to the other side. They're going to cancel out each other, meaning we have x squared minus 4x. From this step here, we can take out our common factor, which is x minus 4 equals to 0. Now your x is equals to 0, or your x is equals to 4. Now remember, I said it's very helpful to go back to check your answer, right? Now here we have 0 as one of our solutions, and we have 4 as one of our solutions. Now if we put 0 here in the space of x and then 0 here, we will not get the same solution on both sides of our equal sign, meaning your x will not be equals to 0, meaning you only have one solution, which is x equals 4. Let's move on to our next example, which is 2x minus 3 x plus 7 equals 0. Again, you need to solve for x. Now here they have foiled it nicely for you. Can you see? Meaning what you need to do is just write it in terms of x, and then get your factors, and then get your factors. Let me rewrite it again. Equals to 0, or your x plus 7 is equals to 0, meaning your x will equal, if we take the 3 to the other side and divide by 2, your x will be equals to 3 over 2, or your x would be equals to negative 7. Your x will be equals to negative 7. So this is straightforward factorizing the expression. So you simply factorize this expression. So this was nice and straightforward. All right. Now we have dealt with everything that you need to know about quadratic equations, and under what circumstances, or under what type of expressions that you will get, and what do you need to do, and which method you need to apply in order to get the correct answer. Now we've dealt with factorizing quadratic expression, and then we've dealt with completing the square, and then we've dealt with using the formula in order to solve your expression, and then we dealt with substitution. These are the 4 important methods that you need to understand, and that you need to practice now and then. You need to practice now and then. That brings us to the end of our session. Hopefully, like I said when I started the session, I was able to give you one of those light bulb moments where your face actually brightens up, and then you say, oh, this is how you do this. And thank you guys for tuning in, and watch the videos, repeat them if you need to, and repeat the problems that you get, or try to get as many question papers as possible, and try to solve as many questions as possible, because once you do that, and once you do that repetitively, you'll be able to master whatever section that you're dealing with. Thank you for joining me. Looking forward to our next session. Thank you.